Today's post is going to be a little different. I'm going to just introduce you to the concept of Cohen's Kappa if this is something you're interested in calculating with Studio Code. I'll show you some of the scripts today, but also I just kind of want to get you familiar with what type of data you would use to calculate Cohen's Kappa. So basically it's a form of iterator reliability for categorized or classified instances. So, for example, say I have codes of student response, and then I ask two raters to label them as either incorrect or correct responses. This would be where Kappa could be useful in calculating iterator reliability. Another example would be if we had a whole bunch of instances of behavioral outbursts, and then we wanted to classify them or categorize them as either mild, moderate, or severe. We could have multiple raters code that, and then calculate Kappa to look at our iterator reliability of that classification process. So this is a little different than actually finding agreement upon the instances themselves. This is agreement in how we're categorizing them. So that's an important distinction to make when you're trying to decide what type of iterator reliability to use. So with Kappa, it's more than just percent agreement, like it was in the past. That in other methods I had showed you, it also accounts for any kind of agreement by chance. So if we think about student response, we can only pick either correct or incorrect. So there's got to be a small chance that we might have just by chance picked the same one. Kappa takes that into account. Look at this matrix at the top. Let's say I had two raters. You can see rater 1, rater 2 on the side. If we had two options, correct and incorrect, all of the frequency counts of our agreement could fit into one of four categories here in this matrix. Everything in A would be things that we both labeled as correct. Everything in B would be that rater 1 said incorrect, but rater 2 said correct. So that would be a disagreement. So actually, I can show you this here. Let's say I'll circle A as with green because that is an agreement. B is a disagreement. C is also a disagreement because rater 1 said correct, rater 2 said incorrect. And then D is an agreement because they both said incorrect. So hopefully you can see kind of this path along here. Those are our agreements. And then the red circles are our disagreements. So that's the first step in calculating Kappa. You can see if we had more than two choices, this matrix would get larger. And I will show you an example of that with Studio Code because the scripting is going to get more tedious at that point. But the process is really very much the same. So down here, I've just kind of explained in words what I just talked about. So what's important within Studio Code is that you have one code and you've already coded a video with agreed upon instances. So the instances are there already. You know exactly how many total instances there are, and then you're going to give them out maybe to your different raters to classify a certain way. So one code, but you need two sets of labels, and you want the text labels to look different for rater 1 and rater 2. So as you can see here, I've shown you some example of how you would script the totals for A, B, C, and D. We need to get those frequency counts to calculate Kappa. Okay, let me erase this here because I know this is where it kind of gets confusing if you don't come from a stats background. We need to get values for these cells. We need to get the actual frequencies for each of these cells. And we also need to get the expected frequencies for A and D, the agreement cells. So we'll talk about that in a second. So to get the frequencies, here are some scripts that you could use. You can basically have labeled some variables here. So I called it $A to match with the A box over here. So $A is basically I'm saying to count all the times where rater 1 says it's correct and rater 2 says it's correct, because that's what A equals, remember? And then where the row equals whatever that name of your code is. So this is the pattern you're going to follow to do this. Then B, which is this one over here, is going to be incorrect for rater 1 and correct for rater 2. And then C is correct for rater 1, incorrect for rater 2. So if you can see the pattern there, basically I'm making a whole bunch of variables. That's what that $sign equals. And I'm asking Studio Code to calculate a total frequency. That's what the word count does. So that's the first step. We need to have those frequency counts that I talked about for each of those cells. Then, so I've got these cells here again. If you think about what the formula for kappa is, it's right up here. I need to know the total number of agreed upon instances, okay, which would be A plus D, those frequencies. And you subtract the agreement expected by chance, which we haven't calculated yet. I'll show you how to do that. And then you take that value and divide it by the total number of instances, which is A, B, C, and D, all the instances together, and you subtract that same agreement expected by chance. That's how this particular statistic takes into account chance. Okay, so now we're going to calculate that expected chance. I think this part, the total agreement's pretty easy to calculate the total, the numbers that are here and then the total, adding them all up. You just use those variables here. So you do $A plus $D would be the agreed upon, and you could make that your own like this. You can make a new variable like that. And then you could do the same thing for $total. Making a whole bunch of variables that makes it really easy to calculate at the end. The expected frequency by chance is actually, it's going to be the sum of two values. To get the expected frequency of A, that's saying if we purely guessed, how many should be in that correct column if we were just purely guessing. So to do that, basically, the formula says add up the row and add up the column. Okay, so whatever the frequency counts were, you're going to add those up and multiply them together, and then divide it by the total sum from the whole box. All right, that's what this formula here shows. I added up $A and B, that's the row, and I multiplied that by the sum of A and C, that's the column, and I took all that after I multiplied them together and divided it by the total, A, B, C, D. That's a lot, but I will make step-by-step directions for you guys as well. So you get the expected frequency of A, and then you're going to get the expected frequency, if we only purely guessed, for D as well. And that's going to be adding up row 2 and column 2 in the same way and dividing it by the total frequency. This probably seems like a foreign language to you if you've never calculated kappa by hand before. But I'm going to, like I said, with that step-by-step direction, hopefully you should be able to follow these. I just wanted to give you an idea of what this process looked like. So you're going to get the total agreement expected by chance. Remember that the formula for kappa, we need to know that, is just adding up the expected for A and the expected for D if we only purely guessed. So just by adding the two of them together, that's going to give us that agreement expected just by chance. So then you can take those same variables and easily have Studio Code calculate kappa with a formula right here. And what you're going to get, if you did it right, you'll get a value that's between 0 and 1. I guess it could be less than 0, meaning like you guys were coded so differently that it was less than expected by chance. But that's usually pretty rare. So typically it's between 0 and 1. And when you're interpreting that, you want to have, you could see here on this scale here, between moderate and almost perfect, I would say above 0.6 would be good for agreement. If it were my research study, you really want to aim for above 0.8 for kappa. But this scale can help you interpret that. So this was a whirlwind of information all about, I guess it's really a mini statistics lesson. What I'll do in my next post is I will turn all of this into a PDF cheat sheet, and I will show you what this looks like, all those scripts right in Studio Code.